Ron said, I'm the Western Area Manager of Hazard Control Technologies, and I want to welcome you to the presentation. I hope it's informative. I hope we come away with a better understanding of the hazards that we face when we deal with lithium-ion batteries. And again, as we go through, we'll have question and answers at the end of the program. So by all means, please be willing, and we look for your participation. As Hernan said, today we're going to be discussing lithium-ion battery hazards, and what is a lithium-ion battery? We look at them, and it's a really good source of being able to store energy. We've gone through our lifetimes many different types of battery construction, and by all means, we see how much superior that the lithium-ion are in being able to hold large amounts of energy. And it requires the positives and the negatives to be able to cross back and forth, charging and discharging. We get into the rapid charging, and all of these things do create some heat. And when we sit there and we start looking and we start to really look at the concerns and the demands, they're everywhere, and they continue to grow. And it's not only the demand for more batteries, but it's a demand for batteries that can hold even more power, a more versatile battery. So the diversity is constantly growing, and the applications are growing. And things that we need to understand when we talk and we look at that is the toxicity that the batteries bring along with it. While yes, we do have the benefit, we also have to look at what happens when a battery fails. And as I mentioned earlier, they're a great source for high energy. When we see them every day. When we look at the batteries, we also have to understand that it's not just the battery. It's the packaging, it's the casing, be a plastic case that's around it or whatever. It's the flammable electrolytes that are used in the makeup of the battery, and then the shock potential, because it is an energy storage system. So when we sit there and we start to look at how these fires can start, again, probably a lot of the common sources are the short circuiting of the batteries. They become unstable. There may be some things in the electrolytes that causes some instability in a battery. It causes them to short circuit internally. We know the trauma, auto accidents in vehicles, dropping, overcharging. We know that we want to be able to use our phones and our appliances, so we're constantly using them and leaving them plugged in, so they can overheat and overcharge. And again, that overheating. We sit there and we hear about people putting cell phones under pillows or things like that as they're charging, which doesn't allow the phone to dissipate the heat, and it causes some overheating. Your phone sitting on the dashboard of your car while you maybe run an errand or something and you forget to move it. So there's many things that can cause that overheating of batteries. And I wanted to play a video
tonight to
from
the
a recent
crash involving one of Tesla's cars with an autopilot feature. The car slammed into a tree and burst into flames. Police tell ABC News it appears no one was in the driver's seat. Here's ABC's Gio Benitez.
Tonight, mystery surrounding a deadly crash near Houston involving a Tesla Model S. The charred wreckage captured on camera after it crashed into a tree and burst into flames. 2 men inside were killed. The Tesla's high-energy battery reigniting over and over again. Firefighters trying to put the fire out for 4 hours with more than 30,000 gallons of water. The fire eventually put itself out. Now tonight, the question, was the Tesla running on autopilot? Firefighters found the men in the front passenger seat and the back seat. Police telling ABC News there's no indication anyone was in the driver's seat. Authorities say the men had just dropped their wives off at home and wanted to take the Tesla out for a test drive. Evidence at the scene allegedly showing it was going very fast.
So There's a couple things, and as I go through the presentation, I'm going to come back and I'm going to talk to you about, and we're going to talk a little bit more about it, because when we sit there, we start looking
Next tonight to the
at
deadly
some of the
crash.
guidelines and some of
Tonight
the
to this
things
deadly crash involving.
we hear about lithium ion batteries, that I hopefully will clarify and point some things out. But one of the things that I want to show now is another video real quickly here as far as an industry. You know, these lithium ion batteries are everywhere. We're in warehouses, we're at our auto dealerships, our collision shops, our homes, power tools, our construction areas. We're relying more and more on the e-cigarette. And as the use of the batteries grows, so do some of the dangers. Many of you followed that Tesla fire. There was a lot of discussion about just having let it burn. I'll talk about that a little bit as well. Here you have a robot that was being worked on at a NASA lab. It took a break. Hilo being used in a warehousing facility. The applications and the use of these batteries are growing. The question becomes, are you prepared? So, as I mentioned through the program, these batteries are becoming more and more popular. And the technology continues to grow, where batteries are being able to store more energies. Instead of some of our vehicles that used to only be able to go a couple 100 miles, now they're doubling and tripling those distances by being able to design and make batteries that hold more energy. And with that, of course, comes some of maybe the hazards around them. When we sit there and we look at our hybrid vehicles, we need to consider those charging stations, not only at home, but how about in our parking garages? How about in parking lots or dealerships, welding and assembly robots, repair facilities? When these vehicles become involved in a minor accident, again, there's that trauma. We need to consider those. As we mentioned, our electric tools and supplies, and then our towing companies. When these vehicles become involved in an accident and they're being towed, are they familiar enough with the batteries to be able to realize the potential that they could be dealing with if that battery, hours after it was involved in an accident, were to begin to fail? And when we look at these charging stations that are being installed in all of these different locations, we don't see any additional fire protection being put in. We don't see an additional sprinkler head. We're not seeing any additions or anything changing that can sit there and help prevent an incident from growing. And when we sit there and start looking, again, at uses and areas on vehicles, fire apparatus, our utility workers, possibly some of their tools, plumbers, and all of the different areas where lithium ion tools are being more widely used. When we look at aviation, we have our loading devices, the ground handling equipment. Our parking garages, again, come up into play, our parking lots and all the areas, the forklifts, the UPS systems, our battery backups, possibly not only for the radars and consumer electronics. How many cell phones, laptops, and other lithium ion powered devices pass through airports on a daily basis? And then again, I bring up your warehouse or your facilities where they're converting from LP gas to lithium ion batteries, these charging stations. Again, if you look at the pictures, there is no additional sprinkler or any additional fire protection in these. We're looking at trying with fleet vehicles, buses, and others. Look at the closeness and how close we have these vehicles and these applications without any way to be able to deal with them. And this is a video of really good example of what you can be dealing with. And here it is, one vehicle.
Jeff, can you download the sound a little, because when you speak, we can listen your voice.
Okay.
Thank you.
Sorry about that. I thought I had it almost down. Okay. Here's an example. A single vehicle at a charging station. batteries fail. And I play the sound so you can hear the aggressiveness, the action of that battery failing. It starts impinging on the vehicle that's close to it, next by. It begins to catch that vehicle on fire. Now, as that vehicle, as this continues on and that fire grows, speed it up here just a little bit. Now the fire grows a little bit, it keeps impinging on the vehicle next to it. The vehicle next to it, the brakes to fail. The vehicle rolls back. And we may think that because it rolled back now, it might make things a little safer. Maybe the vehicle that's next to it might not be involved, but you start to see again the aggressiveness of these batteries as they start to burn, and it starts to impinge on the vehicle next to it, and you're going to have a constant chain reaction. So what was one car quickly become multiple cars, and it become a huge fire. And if we're sitting there and we looked at that one video that I just played at the beginning with a Tesla, okay, 4 hours on a Tesla vehicle, one vehicle. Now you sit there and let's look at 5 and 6 vehicles. Well, let's consider that bus. Well, let's consider multiple high-lows. Okay, we have to start looking at the bigger picture. Here's one of a truck fire. And again, you can hear the sound of those batteries as they fail because of the heat. So they can be rather aggressive. Here we have a airport support vehicle. Here you probably have a vehicle that's used to move aircraft around an airport on the tarmac. You know, what does that vehicle run? You know, $50,000, $100,000. Yet because we don't have the proper extinguishing agent, we're ruining or we're destroying a multi-million-dollar aircraft. I mean, we need to look at some of the things that are being destroyed as a secondary issue to these batteries and not recognizing that there is an agent that can help and control these. So when we start looking now at consumer electronics, our cell phones, our laptops, the gaming consoles, the power tools that we have at home, we know that there was a huge issue with hoverboards there a few years back around the Christmas holidays when there was a big push to try to get them out and make them Christmas presents, and they started to fail. We see more and more communities and more cities looking at these e-scooters and e-bikes to help tourists or help people get around within their communities, the charging stations for them, our kids' remote controlled toys. So again, when we sit there and we start looking at all the uses for these batteries and the makeup of the batteries, they're coming in all different sizes and all different milliamp hours. And, you know, we got our chargers that charge multiple batteries at one time. So again, it's not just a tool. We have a single charger. We're trying to charge many batteries, and in many cases they're rapid chargers. So when we sit there and we start looking at that rapid discharge of using a battery quickly and then trying to rapidly charge it, these batteries are subjected to a bunch of heat. When we sit there and we start looking at our firefighters, our extrication tools up in the upper right hand, again, on the fire trucks, we're putting in these multi-chargers. We're using them for our extrication tools, our saws and everything else. What kind of abuse do you think? And again, it's not purpose, but, you know, being switched from one tool to another tool, possibly being dropped, the vibration of the rolling up and down the roadways on a daily basis. And when we sit there and start looking and we start thinking about, you know, here we have a couple of little videos, again, showing some the things that occur. Here we have a little scooter, like you would see in some of these communities that are looking to these batteries can be. When we sit there and we hear about fires in our homes, you know, fire departments, they decide, oh, hey, it was a cell phone. Yeah, look at sorry, turn that down. How small the battery is in your laptop, but yet look at the energy that's being released as that battery fails. A little e-scooter. Even though it's a small scooter, consider that being in your garage again, or being someplace near your home. Or and we start looking at these communities where they have those scooters parked side by side next to each other near a business, multiple scooters. That one scooter, again, like with the vehicles, can cause a chain reaction and increase, making a small fire into a larger fire. And then we sit there and we start looking at some of the systems that we are facing with our industry. People want to also get off the grid. So they're looking at solar panels, and not only solar panels, but they're trying to figure out ways where they can store the power so that they can reduce their energy cost. We have them in industry. Industry uses them for power shaving. We're getting into the mass energy storage systems where we have our solar farms. What they do is during peak hours, they use those batteries to help supplement and power the grid so that they don't have to go and buy energy from other power sources. They're able to sit there and they're using that during the peak hours, and then during the non-peak hours, they're able to recharge those batteries. And they're able to shave and be able to save some things and help them as far as their customer base. When we look at some of the isolated examples, back in January, there's an airplane that had to be evacuated due to a mobile battery that was burning, or a boat where a battery was burned and 5 persons were injured. And then another airplane needing to be evacuated because of the battery. And then in April of 2019 in Arizona, where we had the battery energy storage system explosion, which injured firefighters. And some of those injuries were career ending. And the list goes on. You know, here we have 90 people evacuated because of an e-bike battery. Just like that little yellow e-bike we saw just a slide or two ago. 90 people evacuated, 9 in hospital because of the toxic gas poisoning that was being released. And then again, you start looking at another, whether it's apartment fire started by another e-bike with, in euros, it was 500, but when we figure that out, almost 600,000 in damage. So the potential in the industry and with these batteries is great. We look at the medical industry. They too are looking at lithium ion batteries because of the length of time and the amount of power that they are able to hold and use. The other thing about your lithium ion batteries versus a lot of the other constructions was when we started thinking about the nickel metal hydrides and those others, they slowly kind of drained down and you know, lost their power. However, with lithium ion, they kind of maintain that power level until they're almost dead, and then it's a really rapid drop in the power. So these lithium ion batteries make all of these medical instruments and even our power tools and everything else much more reliable and easier. And again, we get into those battery backups when we sit there and we have to worry about power failures. And I'm showing all this just to show the diversity of these batteries. We look at, you know, the mining industry, the navigation. We talk about the forklifts and other types of apparatus that may be used in it, the electric tools. And again, I'm going to show the high-low here at the warehouse, and we're going to show the full video this time. When we sit there and we look at the video, you can see it, you know, there's real no abuse that's being taken place with the high-low. The person's just kind of driving it along with a little tote bag. He is off over here, but let's look at what takes place. You're going to see all of the employees doing what they can to protect their jobs in their warehouse. And they're going to run around, they're going to grab their ABC chemical extinguishers. You're going to start see them running into the picture here shortly. And you see one coming in here towards the right. You got one coming in. You're going to see a few more coming in here shortly. and you're going to have somewhere in the area, once this powder starts to clear a little bit, you're going to see about 7 to 8 people with these dry powder extinguishers that we find in all of our buildings and all of our warehouses. And they look like they're having a pretty good effect on being able to control this fire. However, we always hear the main issue with our lithium ion batteries is thermal runaway. When we sit there and we start looking at some of the buses and some of our other applications, again, you know, these storage systems, once they start to fail, these vehicles aren't going to be moved. So the question now is thrown out there, are you prepared? If you have these types of energy systems within your businesses, your homes, the question is, are you prepared? So we just saw the dry chemicals being used. And we saw that when we use those dry chemicals, while they appeared to have somewhat of an effect, they really didn't do much or anything to remove the heat. So we had that reignition. It does nothing to remove the toxic gases that are being released when those lithium ion batteries are burning, and they can't extinguish that fire effectively. And here's another video, and this is showing it's 182 batteries. They're charged to 95%. And again, it's showing the ineffectiveness of lithium ion, of dry powder on a lithium ion battery. So very little to no effect on those batteries at all. Again, we're dealing with that energy, that thermal runaway. We need to be able to cool. So then we need to talk about foam. Generally within the fire service, you know, it's water, more water. And when that doesn't work, we then sit there and think that foam is the solution and the answer. But again, what do you do at night when you're cold? You pull up a blanket. What does the blanket do? It helps keep the heat in. But what does a foam blanket do? Okay, all those bubbles create that blanket that's doing nothing to remove the heat. If anything, it's helping to retain the heat. Okay, when it comes to the toxic gases that are being released while these batteries are burning, the foam is doing nothing to have any type of an effect on that. So again, it's not an effective extinguishing agent when you sit there and you start looking at lithium ion batteries. And again, 182 batteries, they're the 18650 cells, 95% charged. We see as they sit there and they start making their approach, using the foam. If anything, to me, it appears that you're even getting a more aggressive fire than you did when you were using the powder. The foam is absolutely doing nothing to help extinguish that fire. When we talk about inerting gases, and especially with some of our energy storage systems, that was and seems to be the solution. And when we look at those inerting gases, in most cases, the inerting gases are excellent when you look at switching and data centers, and you're looking at areas where you may have some type of an electrical short circuit or electrical fire. But when you're dealing with a flammable liquid, as in the electrolytes of the batteries, and you start looking at the heat that those batteries are generating, those inerting gases, they can sit there and they can create an atmosphere where maybe it can't burn, but it's doing nothing to cool or extinguish the batteries, which was the case with Arizona and the firefighters. Okay, while the inerting gas may have activated correctly and it may have smothered the fire, it did nothing to eliminate the heat. It did nothing to remove the flammable nature in the gases. So when they opened up the door to gain access, they had an explosion causing the injury to those firefighters. Things we need to consider when we look at the design and we look at those types of systems. So there's minimal cooling with them, and it doesn't stop your thermal runaway. Again, the reignition and those toxic gases. It's doing nothing to help eliminate or reduce those toxic gases. So there's very little effect that those inerting gases will have on your lithium ion batteries. And just as an example, again, I'm going to play a video that shows the robot that was being worked on. Engineers left for lunch. The robot decided it was going to go ahead and catch itself on fire. Batteries failed. They come in with a CO extinguisher, which was their plan to deal with that type of a fire. And as you can see, very little to no effect. He's coming in with another one. He seems to extinguish it. It looks like it's pretty good. But again, I want to point out, look, all the gases being released, the toxins that are being released by those batteries. And those batteries actually do reignite and catch on fire. Now, the next thing is water we're going to talk about. And I want to go back to that video that I showed at the very beginning and discuss that video. When we sit there and we looked at the news clip, it was 4 hours, 30,000 gallons or more of water. Where did that water go to? And when we sit there and we start looking at some of the different reports where people say, yes, water can be used to extinguish batteries, it's always a copious amount of water. And I asked the question, how much is a copious amount? Well, we are now getting a guideline. You know, it could be as much as 30,000 gallons of water, and then we give up and we just let it burn. So we don't know what a copious amount of water is. Water is not ineffective because we also have data and we have reports where when these types of batteries have been extinguished, hours to days later, they can reignite. They can catch on fire again. So now I go back to that tow company where you had a vehicle that had been in fire department put it out, and they tow it to their tow yard, and they start putting it next to other vehicles. Okay, if it's involved in some type of a criminal activity and the police department's towing it into their impound yard, you know, the abilities for a disaster with these types of incidents can be, I mean, great. Things we need to consider. Water, again, does nothing to remove the toxins that were being released, as I was showing in that last video with the robot. And again, that copious amount and time consuming. Like I say, the fire department with 4 hours on scene, 30,000 gallons of water, copious amounts. Okay, so is that what we're calling a copious amount of water? And again, 30,000 gallons of water, and we have a completely and totally burned up vehicle. Had little to no effect of being able to extinguish this fire. And when we sit there and we start listening to other reports and things like that, you know, the actual extinguishment from the fire is being reported to be like 24 minutes. But the rest of the time it's trying to cool the batteries, because when they would stop flowing water, it would reignite. So after that 30,000 gallons, they pretty much just gave up and they let it burn. So the question now becomes, you know, this is in a parking structure. Are we going to just let it burn? Or if it's in a residential neighborhood where you can have multiple houses catch on fire, the let it burn mentality and that thought process isn't one that I would be considering, or we have to try to get the fire service and our emergency responders to get away from. So now let's talk about the encapsulator agent and what it's going to do for being able to deal with these types of emergencies. And to start with, so we understand what an encapsulator agent is, it's not a foam, it does not create bubbles. We don't work on a mechanical basis by making bubbles. We're working on a chemical basis, and we'll see that in a minute. But one of the things that we're very proud of, because it's a huge issue all across the world, is the PFOS and the PFOAs. Encapsulator agent F500 is 100% fluorine free. It's non-corrosive and biodegradable. It's multi-class NFPA listed AB suppression agent and a flammable, combustible vapor liquid spill control agent.
Encapsulator technology, the next generation of fire and hazard mitigation.
So we can
First,
see
we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So it's very important. I'm going to kind of go back to that slide and go to the very
Encapsulator
end.
technology.
Very important that you understand
Encapsulate.
the molecule that makes up an encapsulator agent. As I said earlier, when you talk about foam, we're talking about a thin wall bubble structure. As you can see, when we're talking and we start putting an F500 encapsulator agent molecule into the water, we're creating these micelles, these spherical micelles, millions and millions of these spherical micelles. So I'm not working on a mechanical basis as a foam bubble would. I'm working on a chemical basis, forming cocoons that will hold the flammable liquids that'll encapsulate those toxins and the hazards that are associated. But at the same time, I'm forming a skin on the surface of the water molecule, on the surface of the water droplet, which helps is being able to rapidly cool and extinguish these fires. So it's not water that I'm dealing with. I'm dealing with our spherical micelles, and I'm dealing with that skin that we put on the surface of the water. So again, it's got a polar head, that non-polar tail. As it comes out of the nozzle, the molecules closest to the surface, the spherical micelles that are closest to the surface, they start to break apart and they form that skin on the surface. And it's important that you understand how they work so you get a better idea of what it does and how it's able to extinguish these batteries and stop thermal runaway. We encapsulate the electrolytes. We rapidly reduce the temperatures. And I'm going to show some videos where we sit there and we start looking at all of these properties. And here's an example of a battery that was basically used in testing. It shows how to the right, all of these batteries have gone into thermal runaway and they were sitting there and they were failing. And when you sit there and you start looking to the left, you'll see that they did not continue, that once the agent F500 solution was applied, they were able to extinguish and stop that thermal runaway and having any more of those batteries be involved. When we looked at the gas coming off the batteries with that robot, okay, in most cases, depending on the construction of the battery, it's hydrogen fluoride. Hydrogen fluoride is a very toxic gas. As one video showed, it sent people to the hospital when they were burning from an e-bike. So imagine a Tesla or something more where there's even more of those batteries that are involved. So we're going to see some videos. And again, I point out the rapid cooling and how an encapsulator agent is able to stop the thermal runaway. We're going to be able to encapsulate those flammable electrolytes. So not only am I going to stop the heat source, I'm also going to get rid of that flammable property of the electrolytes. And I'm going to show that that encapsulation property of F500 EA is also able to reduce the toxicity and the gases that are being released. And it is highly effective on being able to stop thermal runaway. So we've seen, I played the video earlier where we showed the powder, how ineffective it was. And I showed with the foam and how ineffective it was. It just made it more aggressive. But watch over here on the F500 as he makes his approach. He's not using a constant spray like he did with the foam or the dry powder. I mean, he first makes his attack and he's just using short little bursts. And look at the effect he's having on being able to extinguish that lithium ion battery pack with just those short little bursts. The effectiveness, look at how little the amount of runoff coming off of those batteries are. And when you sit there and you start looking at the importance of that, some countries, when you are dealing with a automobile fire or a fire involving lithium ion batteries, they need to contain the water and they pay hundreds of dollars to be able to dispose of that water. So if you're using 30,000 gallons or copious amounts of water, it could be rather expensive to start to dispose of that water properly. So when we sit there and we look, this is, again, the published reports from the Kiwa lab results for Johnson Controls and use of F500 on lithium ion batteries. And again, I'll point out Johnson Controls, the largest fire protection company in the world that has done these testing, and they find out that powder, do not apply on your lithium ion batteries. It's a poor extinguishing agent. We look at the foams, and well, we'll give a couple of them a moderate, but again, what's the remarks? Not recommended for application with lithium ion. And then we sit there and we look at our F500 encapsulator agent, and it's worked on 3 different tests, and the recommendation is it can be applied on lithium ion battery fires because it's able to stop your thermal runaway. And just more showing you, it's able to extinguish those batteries without possible explosive behavior of lithium ion batteries. So I'm going to show a few videos of some of these fires where, they've been extinguished with F500. Show the solid state batteries where, okay, your F500 is not making it internally into this particular battery pack, but again, it's able to, by being sprayed on the outer package, the outer pouch, it's able to cool. And it's able to work to stop that ignition and stop that thermal runaway from continuing.
Oh, yeah, that's very
Okay, we sit there and we look at another battery. I like this battery best. I'm going to point out something here. When you sit there and you watch, you see the battery swing up. But the spray is hitting here. It's actually the overspray that's going to extinguish the battery. The main stream is going to be hitting the plastic frame, yet the encapsulator agent just splashing across is still able to control and eliminate and reduce that heat and stop that thermal runaway and extinguish this battery. So yes, I am going to say you do have to get the product onto the fire source. It's not going to magically seek it out. You have to get it on there. But I'm saying, I was just trying to point out, it wasn't the main concentration of the solution that was getting to those batteries. It was just a little overspray. This is some more testing that was done. Again, this is a really good one because we have multiple different sources to help us identify and show it's taking place. On the upper right, you'll see we have some thermal imaging taking place. And then on the bottom right, you're going to see we've got some different types of temperature sensors going on, showing us our temperatures in centigrades. As I'm going to kind of advance through, this is a rather long video, but I'll advance through. We start to see that through the overheat process, we're starting to get a little bit of smoking coming off the battery up here on the top left. Our temperatures are beginning to rise in some of the sensors. We're getting a little bit more heat generated. We can see up here in our thermal imaging cameras. And again, our temperatures are continuing to rise, getting a little bit more heat, getting a little bit more of the off-gassing coming from the batteries. And here we have our ignition of the batteries. We're going to sit there and they're going to allow these batteries again to continue to fail, let that thermal runaway continue to affect the battery next to it. Again, we sit there, we start watching our temperatures continually rise and continually going up. Okay, we're starting to get up into the almost 600 degrees centigrade area on some of the sensors. You can see the thermal imaging showing some really good heat involvement. Your F500 will be applied here in just a second. But again, I want you to watch those temperatures on the side. How quickly, once the application of F500 has begun, watch the rapid drop. And there it goes. Here we come. We're up to 709. Okay, so there we now have the application. So we were, what the heck's going on? Sorry about that. We were at applications that were in excess of 700 degrees Celsius. And once the application started, we've dropped them down considerably. Now we're down in 17 degrees Celsius. So that rapid drop in temperatures is instantaneous. It's very, very rapid, very quickly. And not only that, but as you can see, they continue to drop in temperature with just that short little application. So we sit there and start looking at some of the solutions and some of the services we offer, and we work as much as possible because we understand that, you know, in many cases, this is a new hazard that fire departments and people are being faced with, especially with the rapid growth of the lithium ion technology. So we offer the training, we offer specialized solutions for our agent. We looked at the encapsulator technology. It's a choice of Johnson Controls. It's a choice of Bosch, Tesla, and many other of the industry leaders. And then, like I say, we have fixed and mobile systems that are making it beneficial, such as for QAMU units, when we start looking at our warehouses, or we start looking at areas where there may be a hazard where we have to have a solution to be able to deal with those. We have our compressed air units that come in various sizes. And then I'm going to talk about another solution when we start talking about those parking structures, those areas where we have charging stations. Maybe it's not easy to add on or get a major solution. There's the fire CT is in conjunction with.
Fire Rover is the revolutionary way to stop fires before they begin. Using military-grade thermal cameras to detect abnormal heat variations and up to 20,000 gallons of firefighting agent, Fire Rover protects your business from property loss and downtime. Here's how it works. The thermal camera detects changes in surface temperature. Abnormal heat triggers an alarm and alerts Fire Rover's live monitoring station. Trained operators evaluate the risk and can trigger the firefighting agent remotely within seconds. Operators aim the firefighting agent using both thermal and HD footage. The firefighting agent is 100% biodegradable and effective on metals, petroleum, plastics, agriculture, rubber, general waste, and more, including lithium-ion battery hazards. Fire rover can reach a distance of 150 feet with a radius of 343 degrees. The thermal camera confirms when the fire is extinguished and the surface has cooled, eliminating the need for costly fire watch. Fire Rover is always ready to detect and extinguish fires and keep your operations safe. Contact us today to start protecting your business.
We also have our bladder systems, which can be tied into existing fire suppression systems. The top picture on the left of your screen would be an example of a concentrate control system. On the bottom, just below that, is a picture of the risers where maybe that one tank may be able to supply and protect multiple areas of the plant where maybe there might have some hazards that you want to be able to. The other picture here is another type of a system that can be added in as well, which is a water-driven proportioner. Probably a little bit more accurate and a little less maintenance involved with the water-driven proportioner. So when we look at the CCS systems, this is kind of a busy slide, but there's all different applications that we can use with it. And Hernan is recording this. He'll be more than happy to share with you, and you'll be able to review and look at this even more when you get this. But again, when you look at the different companies and the different people that are using encapsulator agents to protect their facilities where they have lithium ion battery hazards, you'll see we do have a rather diverse and a well-rounded, I guess you can say, group of representation when it comes to the need for being able to protect. So again, as I said, when it gets down to it, are you prepared? And here's a truck fire. So I end with, it's time for us to wake up. It's time to sit there and stop being, we've done it this way for so many years. Let's keep going the way we are. Let's wake up and let's find the solution. Let's create safer conditions for ourselves and our employees. With that, I want to again thank you for attending the presentation. And I now open up for questions.